Hello everyone, how to solve this problem? For the values of k, if we have 3 to the power of k is equals to k, and we solve this problem for all the values of k. So here we need to find all the roots or all the solutions set of this question. So here the very first thing we are going to do is first we need to remove this exponential term, and in order to remove this exponential term, we will take a natural log on both of the sides. So when we take natural log, it will be written as log of 3 to the power of k is equals to log of k. And here we apply the nice logarithmic property. You know about that. If we have log of a to the power of m, it is equals to m times of log a. Okay, according to this rule of exponent, we move this k in the front of this log, and it will be written as k times of log 3 is equals to log of k. And now further in the next step, we move our variable term from left hand side to the right hand side, so that here our k is multiplied by log 3. We need to move this k to the right hand side, and for this we divide both of the sides by k. Okay, each of these terms. So when you divide by k, it will be written as in this form, and here you remember that our k is non-zero. Okay, because we solve this problem for non-zero values of k. So here this k and this k are cancelled out by each other, and we get here log of 3 is equals to, this is log of k divided by k. And further in the next step, here we know about that if you have a number a, and if we apply log and anti-log at the same time on this number, so it will be written as in this form, e to the power of log a. Okay, so according to this, we can write our this k as, so our k is equals to, this k is written as e to the power of log k. Okay, so we replace this k equals to e to the power of log k, and it will be written as, so above equation becomes log of 3 is equals to log of k divided by, we write this term as e to the power of log k. Okay, so you see here this term is lies in the denominator, and here we use the exponential law. You know that if we have 1 over a to the power of m, so when we move it upward, it will becomes a to the power of minus m. Okay, according to this rule, when we move e to the power of log k to upward, it will be written as log of k is multiplied by e to the power of minus log of k. So in the left hand side we have, this is log of 3. So further in the next step, here we need to multiply both of the sides by minus 1. So when we multiplying both of the sides by minus 1, it will be written as, so this log 3 becomes minus times of log 3, and this whole term is written as minus times of log k is multiplied by e to the power of minus times of log k. So I can just explain the reason why I can multiply both of the sides by minus 1. So the answer of this question is in the next step. Okay, so here I want to use the Lambert W function to solve this equation. Okay, so you very well know about that. The definition of Lambert W function is, so the Lambert W function is denoted by w, and if you have w of x into e to the power of x, so we can apply Lambert W function on this type of function. This means that if you have an exponential function and its exponent is multiplied by here, then we apply the Lambert W function. So the output of this type of function is equals to the exponent of e. So here our exponent of e becomes x. So here if I can give you the example of this Lambert W function, if you have some function in this form, w of 2 into e to the power of 2, so the output of this type of function becomes 2 only. Okay, so here we need to use the Lambert W function, and in Lambert W function the exponent of e is multiplied by here, and you see here in our case the exponent of e is minus log k. So we need to make minus log k here, but here we have only positive log k, so that's why we need minus 1. So that we multiply minus 1 on both of the sides in order to make the function according to the Lambert W function. Okay, so now you see here we are ready to apply the Lambert W function on both of the sides, and we easily get the output of this type of function. Okay, so here we apply W function on both of the sides of this equation, and it will be written as minus log 3 is equals to minus log k into e to the power of minus log k. And now when we apply W function on both of the sides, it will be written as in this form. Okay, so this will be also becomes W of minus log 3. And further in the next step, we just the output of this type of function is equals to minus times of log k, and in the left hand side we have this is W of minus log 3. Here our target is to find the values of k, then here we easily get the values of k. So that's why first in the first step we need to remove this negative sign from here. For this we multiplying both of the sides by minus 1. So when we multiply by minus 1, it will be written as minus times of W of minus log 3 is equals to this minus times minus becomes plus log k. And now because our target is to find the value of k, so that's why we need to remove this log k log from the right hand side. So in order to remove this log, we need to take the anti-log on both of the sides. So when you take anti-log, it will becomes e to the power of minus w minus log 3 is equals to e to the power of log k. So after that, you see here the exponent of this e is negative, then we move this term towards downward because it will becomes positive. So we get e to the power of w of minus log 3 is equals to, here you see that this e and this log are cancelled out by each other, and we get here only k. So this is the final value of k which we get here. Okay, so this is our final answer of this question, and thank you so much for watching this problem. Please subscribe to my channel for more exciting videos.